Okay, here we go. We're on page 55 in your notebooks. Like I said before, planners, today we're talking about parallel lines and transversals. Because yesterday I introduced you to transversals. That's just a line cutting through other lines, but today those other lines are parallel. So what's going to happen with angles on the inside? Okay, so we're going to use parallel lines. We'll use transversals, properties of parallel lines. Here we go. Part in your notes, it's all about these postulates. So check it, we can look at the pictures and I can teach you from the pictures. So here we go. This very first one is about corresponding angles. Well, corresponding angles, angle 1, angle 2, nod your heads, do you agree those are in corresponding spots? So they're still corresponding angles, but watch. If this is parallel to this, if and only if those two lines are parallel, then corresponding angles are congruent. They'll always be the same measurement, but that's only if those lines are parallel. So right over here, you can write congruent, or you can use the symbol if you prefer to shortcut it. That means congruent. Remember, that's only if the lines are parallel though. Quite convenient. I hope that's logical. When you look at it, they look like they should be equal, don't you think so? Only if they're parallel though. Okay, next one is about alternate interior angles. Well, alternate interior angles, guys, check these out. Nod your heads. Do you agree 3 and 4 are in alternate interior spots? Yeah? Okay, if and only if these two are parallel, then alternate interior angles are also congruent. Quite convenient. Alright, so same thing. These ones are congruent. What do you think? Shortcut it. Well, don't shortcut it, but guess. Do you think they're all going to be congruent? All pairs? All types? Okay. Alright, let's see. Okay, so another pair we need to talk about. Okay, consecutive interior. These ones are not congruent. Don't ever put consecutive interior congruent. Look at them. So these ones, as long as these are parallel, these ones are, what's the vocab word for 180 guys? They're supplementary. They're not a linear pair. Why aren't these ones a linear pair? They're not right next to each other, formula line. Linear pair does stand for 180, but be careful. Linear pair literally means they're right next to each other. So these ones, consecutive interior, are supplementary. So be careful with that one. Don't set them equal to each other. We'll do an activity tomorrow that practices with that a lot. Okay, alternate exterior, check. 7, 8, definitely in alternate exterior spots. These ones, as long as that's parallel, what happens, guys, to alternate exterior angles? They're congruent. Those will be the same measurement every single time. So again, these ones are congruent. Okay, last one is a perpendicular theorem. I'm hoping this one is like, yeah, that makes sense. So this theorem, guys, is saying you've got this parallel line right here getting cut by this transversal right here. Let me highlight that. So this parallel line cutting with that. Well, if that forms 90 degrees, but you know that this line right here is parallel to this line, what do you think is going to happen with this transversal one right there? It has to be 90 degrees. It'll still be perpendicular to the other line as long as they're parallel. So I'm going to use my perpendicular symbol. It's still perpendicular to the other line. I hope that's logical. Thumbs up, does that make sense? How else would it be, right? If it's going to cut, we couldn't tilt it at all. Okay, let's start practicing these. Okay. Such popular questions. They give you one angle and then everything kind of falls into place. We're going to walk you through this one. So right here, all that's given to you is that angle 1 right here is 118 degrees. So letter A, we have to find angle 2, and then angle 3, angle 5, angle 4. Okay, here we go. So angle 2, stop and just go to the picture. What kind of angles are angle 1 and angle 2, do you know? Good job. Guys, right here, that's our reason. It says, tell which postulate or theorem you would use. So we're just going to put linear pair right here. Linear pair postulate if you're being perfect. All right, they're a linear pair, so we can just take 180, subtract angle 1, which is 118. Guys, what's 180 minus 118? Yeah, 62. Good job. So angle 2 will be 62 degrees. I always go back and write it in my picture. Okay, now we know angle 2. Now it's asking for angle 3. Oh, it gave you a hint. Angle 3 equals something that we already know without figuring out the rest of them. Ellie, do you know which one?
Yeah, it's number 1.
Yeah.
Because
Do you remember what?
the C word.
They're corresponding angles. Good job. They're totally corresponding angles. Therefore, they're equal. Good job, Ellie.
But, Miss David?
Colton, go ahead.
Couldn't angle 4 be congruent as well?
Yes.
Equal?
Yes. We're just following this one, but yes, go with that. Keep going. Okay. So letter C. Wait, which one did we just figure out? We got it right in the picture. So we said angle 3 is 118 degrees, right? All right, letter C is asking about angle 5. Oh, check out your picture. It's saying angle 5 equals something without having figured out. There's some type of angle that we already have, either red, purple, or green. Tyler, do you see it? 2. How come? What kind of angles are they?
They're alternate.
Yes. So by alternate interior angles, we can say that angle 5 equals angle 2. So angle 5 also has to be 62 degrees. So it kind of falls into place. And then this is what Colton was saying. Angle 4 equals what angle?
Angle 3.
Sure, it equals angle 3. Why? Vertical angles. It equals another one by something else. Do you know? Angle 1 by what? Alternate exterior. So whatever you see, go with it. You'll still get the same answer. So we can say measure of angle 4 equals measure of angle 3 by vertical angles. Or maybe you didn't see that. Vertical angles postulate. Maybe you said measure of angle 4 equals measure of angle 1. That's all going to be the same thing. They're both 118 degrees. This one, your reason would just change, but I don't know. Whatever you see, go for it. Because this is exactly like your assignment today. You've got to figure out what the angles equal, but you have to say why. So corresponding, alternate interior, alternate exterior, linear pair, vertical angles, one more, consecutive interior, any one of those. Thumbs up, how do you feel about that? That makes sense? But it's kind of nice because you don't have to follow someone else's fill in the blanks. You get to do it on your own. Okay, here we go, this one. So real life example. You've got this parking lot here. It's saying M is parallel. Do you remember that these symbols mean parallel? Feel free to use them whenever you want to. So right here, that just means parallel. Okay, so we've got this line right here. It's parallel to that line right there. And we've got this transversal cutting through it. So, do you know the relationship between angle 1 and 80? What kind of angles are they? Okay, they're definitely interior. But alter means they'd have to be on the opposite sides, right? Consecutive interior. So right here for our reason, let's put consecutive interior angles. So consecutive interior, guys, are they equal? No, they're supplementary. So they walked you through it. So measure of angle 1 plus 80 is going to be supplementary, 180 degrees. Subtract 80 from both sides. Guys, what's angle 1? There you go. Perfect. And that, literally, we just use our algebra skills. We subtract it from both sides. Subtraction property. Okay, we're at the bottom of the next page, right? Of the same page. Okay, here we go. I'm going to stop the recording because I want you to try this on your own. However, you've got to say what angle 7 equals, but you've got to tell me why. Is it alternate exterior, alternate interior, consecutive interior, side interior, corresponding, vertical, linear, anything that you notice. Make sure you put an answer, but then why. Go for it. Try it. Okay, show me with your fingers what number you're on. 1, 2, or 3. Or 0 because you're done. Let me see. 2s and 0s? That's crazy. Oh, I see a 3. There we go. Okay, well, let's at least talk about number 1. Before I do anything, I take what they gave me. So angle 6 is 53, and I always just write it in. So this right here is 53 degrees. All right, and then number 1 is asking about angle 7. Can I get a hand in there? Will you tell me how you figured out angle 7? What did you use? Annie thinks, what'd you do? Alternate interior. Perfect. So alternate interior, what is angle 7 going to equal? Perfect. 52 degrees. That's all I need to see for this one. Guys, raise your hand. How many of you got that? Same as Annie? Good job, good job. I always come to the picture and I write it in. Okay, what about number 2? It seemed like some of you were stuck on number 2. Hand in the air for number 2. Do you know how to figure out this one? Oh, okay, look at all these hands. Callie, what do you think?
Linear pair.
Linear pair. Perfect. Linear pair with which angle, Callie?
Angle 7.
Perfect. Linear pair with angle 7. So linear pair, walk me through what you did, Callie.
I did 180. Linear pair and subtracted 53.
Perfect. And what did you get?
So 127.
127. done. How many got the same thing? Yeah? Nice. Question, Alec?
How is it a linear pair?
Great question. He's asking how is it a linear pair? Right here, Alec, 7 and 8 are right next to each other. They've got this cut through it. So they're literally next to each other. There's the pair.
So you just go off of 7? Like I was going off of 6 and 8.
Oh yeah, 6 and 8, unfortunately there's no relationship between 6 and 8. So you can use anything you know. Great question. Thank you. Alright, angle 9, can I get a hand in the air? I'm kind of curious what you did for this. I know what I would do, but I'm not the same. So Maddie, what'd you do for this one? Vertical angles. Vertical with what other angle? With 8? Alright, so vertical angles with 8, so what does angle 9 equal? Perfect. Oh yeah, I forgot to put on my picture. So if this is 127, vertical angle is 127. Did any of you do the same as Maddie, vertical angles on that one? Oh, tons of you. Did any of you do something different? Yeah, what did you do, Annie? Consecutive interior right here, 9 and 6. Totally work. We'll get the same answer. So that's nice about this. No matter how we see it, we'll get the same thing. Okay, let's go to our next problem. I think this one uses algebra. Yep, okay, I'm going to color over this. It can be helpful, but sometimes it's a little more confusing to fill out someone else's work. Okay, let's just walk through this together. Use properties of parallel lines to find the value of x. Okay, this one right here, guys, does that mean 1 degree? It just means angle 1. You know that can be confusing sometimes. So hand in the air, does anybody want to get us started? Or James, what do you want to do? Perfect. Angle 1 and 39 are definitely alternate interior angles. Because what do we know about alternate interior angles? They're equal. So now we know angle 1 equals 39. So I just come in picture and I write that in. 39 degrees. Okay, how is that helpful in finding x? Does anybody know the setup on this one? Colton, what would you do? Linear pair. Nicely done. Okay, Colton, be more specific. Tell me your setup now.
I would angle 1 and 7x plus 1.
Perfect.
I would add those together,
Okay, add them together.
and then that would give me 30 or 40 plus 7x.
Okay, you're ahead. Let me write it down. So we've got add them together, they'll equal 180 because linear pair is always 180. So you said 40 plus 7x, okay, equals 180. Then what, Colton?
And then I subtracted 40 from each side.
Subtract 40 from each side. Hold on, I'll clean it up. 7x equals 140. Okay, now what?
You divide by 7 on each side.
Divide by 7 on each side.
And
Well,
then
go
x
ahead.
equals,
20. Because your chance got to huh? Not too bad. You can use anything you need to finish the problem. I love that you said linear pair. I love that James started us with alternate interior angles. Okay, let's go to the next two. Next, I think it's more of these. So, yes. Okay, use what you know. Now this in the directions just say use properties of parallel lines to find the value of x. But guys, will you also state your reason? It's good practice. Okay, go for it. Start solving number 5 and number 4. Okay, will you show me with your fingers what number you're on? Number 4, hold up 4 fingers. Number 5, hold up 5 fingers. Or 0 because you're done. Okay, we've still got a few 5s. Let's go over number 4 then. Can I get a hand in there? Will you walk this one? Okay, Lauren, what did you do for this one?
Well, dx is corresponding to the right angle.
Nicely done. She said 3x is corresponding to the right angle. Perfect. So Lauren, give me the setup. What was your setup?
So 3x is equal to 90 degrees.
Perfect. So tell me how you solved it.
I just divided by 3.
That's it. Not too bad. Divide by 3 on both sides. X equals 30, right?
Yep.
Because raise your hand if you have the same as Lauren. Yes, good job. How many of you put corresponding just like Lauren did? Fantastic, Lauren. All right, number 5. Can you get a hand there? What did you do for this one? Can you tell me your reason too? Ali, what did you do?
Divided in alternate exterior.
Okay, so your reason is alternate exterior. Can you tell me your setup then?
And since they're equal, you can just do 7x plus 1 equals 10x.
Perfect. They're equal because they're parallel lines. All right, so Ali, keep walking me through what you did. I'm kind of annoyed though. All right, go ahead.
I added 50 plus
Okay, add 50.
and I subtracted them.
All right, I'm going to change the color. So you did 2 things at once. So you subtracted x also. All right, so that'll leave you with 51 on this side, 3x on the other side?
Yep.
Okay, keep going.
And then divide by 3.
Divide by 3.
X equals
raise your hand if you got the same thing on that one. Yeah? Good job, good job. Okay, this one, do you remember the very last, number 4, the very last theorem we talked about? I don't remember which one, I just remember something about perpendicular. Could you have used that for your reason? Sure, you totally could have used that. Colton, was that your question?
Yeah.
Yeah, absolutely. Same thing. Are we done with our notes already?
Yeah.
Sweet.